Hi students, welcome to lesson 5.3, Interpreting and Sketching Graphs. Alright, example 1. So example 1, we're going to describe a situation and we want to figure out which graph represents this situation. So a group of city workers have to plant a large number of seedlings. Which of the following graphs model realistically the relationship between the number of workers involved and the time it takes to complete the job? Alright, so first of all, let's make sure we understand the situation. The more workers you have planting, right, seedlings, probably the faster the job's going to go, right? So if you have a small amount of workers, that job will take a long time. If you have a large amount of workers, that job will take less time. Alright, so if we take a look at these graphs, okay, so let's try to understand what all these graphs represent and then come up with our answer. So here, as the number of workers increases, the time it takes increases as well. So that shouldn't make sense, right? The more workers you have, the less time it should take. And the second one, the number of workers goes up, the time taken, see the y value here, goes down. So that makes a lot of sense for our graph, but let's go over all of them. So here, the time taken, at first, if there's a small amount of workers, okay, so the more workers you have, okay, the less time it takes. So this could be a good representation of it. Okay, so D, so time taken goes down, but notice that after a while, that the amount of workers, okay, then the time goes up again. Probably not a representation because, again, the more workers we have, the less time it should take. Okay, so this is an increasing function, so the more workers, the more time. That shouldn't make sense. And here, another representation of a possible answer is that the number of workers goes up and the time goes down slowly. Okay, so I think any of these three would probably be a good representation. To be exact, I think we'd have to get more information because this would be a linear function. So it means that every worker would decrease the amount of time the same amount. Okay, and that's not necessarily the case, right? So this would mean at first, if you add a few workers, right, the time taken would go really down real quick. But after a while, if you've got too many workers, well, the time saved won't go down as fast. Okay, so here, this one, if the number of workers goes up, the time taken does go down at first slowly. But if you've got a lot of workers, it goes down a lot faster. So again, I think we need more information. Most likely, this is the answer here. But I think that C and F could also be possible solutions. Alright, example 2. Every morning at camp, one of the scouts hoists a flag to the top of the flagpole. The graph shows the height of the flag as the function of time. So this is the height, so the y would be your height, and time would increase this way. Which do you think models this situation more realistically? If you think none of the graphs are realistic, draw our own. Okay, so it also asks, before we go too far, any of the graphs represents an impossible situation. Alright, so let's take a look. So first of all, let's again understand the situation. So notice that the height of the flag will go up, right, as time goes is going up. We're gonna figure that the height of the flag is going up at the same speed, but it's not necessarily the case. It might be a little harder at the beginning and a little easier at the top, vice versa. Alright, so let's look at the first graph. So here the time increases, the height of the flag increases. That could definitely be a possible situation. In B, the time increases. At first, the height of the flag goes up really quickly. Maybe at the top it's a little bit harder, so the height of the flag would slow down. So again, this is a possible situation that could come up here. Okay, so the height of the flag here, it would go up a little bit, and then up a little slower, up a little bit slower. So notice that it would go up, okay, and then it would go up quickly, and then it go up, and it would. So this is, I think, a little bit unlikely because here it goes up and then goes up quicker, and then goes up really fast, and then slows down, and it goes up really fast, and then slows down, goes up really fast. So this actually could be a good situation where you're thinking about your hands. So you would go drag up, and it would slow down, drag up again, slow down, drag up again. So this is actually a really good representation. This is probably our best answer, actually. So here, the height of the flag according to time, so at first it doesn't go up very fast. At the end, it goes up really fast. So that would be, it's really difficult at the beginning to start to getting it going, and then at the end, it's going to go up extremely fast, all the way to the top. Here, the height of the flag, it's going up slowly at the beginning, it goes up really fast in the middle, and at the end, it slows down to a halt. Again, that's probably a pretty good representation too. In F, this is an impossible situation that we talked about. Because think about it. Here the time remains constant. So here that time equals, let's say, 2. The height of the flag would go up instantly. So that would be, this is an impossible situation because there is no increase of time. So it's saying that the height of the flag would go up when the time would not change. So this is impossible. Alright, in our last example, we're going to take this graph and try to analyze it a little bit. So here's a graph of the vending machine use at a large cafeteria company. Okay, and they sell soft drinks in their machine. The graph shows the number of cans in the machine on a typical day. Alright, so the day starts where we have 250 cans, and all of a sudden at 8 o'clock, the number of cans goes down. Okay, at 10 o'clock, it goes down really fast. Okay, and right around, I don't know, 10:30, it starts going back down to its regular constant decrease. Then all of a sudden at around 12:15, maybe 12:30, in that time range, it instantly goes up really quick, right? It goes up really, really fast, and to about 400. And then at 12:30-ish, okay, so again, this is probably about 5 minutes. At 12:30, it continues to shoot down rapidly up until about 1:30. And then it has this constant rate of decrease, same as the 8 to 10, between 1:30 and 4, and all of a sudden at 4, it has 250 cans again. Alright, well, what happened? Let's describe that situation. So when are the morning coffee breaks and lunchtime? Well, I think it's pretty obvious that there is a coffee break probably right around here, because if people are thirsty, they want to go get themselves a drink. So between 10 and 10:30, there is probably a coffee break. So between 10 and 10:30 would be a coffee break. And now when would be lunchtime? Well, if you think about it, lunchtime, they probably refill this machine right before lunch. So we're going to say lunchtime's probably at 12:30, and it probably lasts all the way till 1:30, right? Because that's when the decrease of cans goes down quite dramatically in a short period of time. So we're going to say lunch is between 12:30 and 1:30 is lunch. Okay, now what happens just before lunchtime? Well, I think we described that when we talked about this peak here, is they filled up the machine. So they filled the machine before lunch. Okay, next, can the employees use this drink machine during work hours? Well, notice that during work hours, probably between 8 and 4, the machine does decrease in the amount of cans. So obviously in this situation, they are allowed to, because, and I'm right because here, because machine is losing cans during whole workday. Okay, and D, how many cans of drinks were sold during this day? Oh, okay, well that's an interesting piece of information. Okay, so now we started at 250. We went down 200, so that's 50. We sold 50 here between 8 and 10. Okay, and then we sold all the way down to 100, so we sold another 100. So really, on this time period between 8 and 12:30, we sold 150 cans. Okay, then we refilled it. And then between lunch and the end of the day, we sold another 150 cans. Okay, another way to look at it is, notice that the beginning of the day is 250 and the end of the day is 250. So really, we just have to figure out how many did they add at lunch. And notice they added 300. So you could either go sold 150 and sold 150, or say, we added 300 during the day, so therefore 300 cans. So 300 cans. And the last example, or not last example, last question. What appears to be the working hours of this company? How do you know? Well, just looking at the data, looking at the graph, I would say it's between, sorry, I need a pencil, between 8 a.m. and 4 p.m. because that's when the machine is being used. That's when it's losing cans, right? So when it's being used, it just means it's losing cans. All right, so I hope all that made sense, guys. So again, a lesson on analyzing graphs.